Welcome to the React.js Engineer track. By taking the courses in order, working through the exercises, tests, exams, and practice projects, you will become a software engineer with a concentration on React.js. This will enable you to work on projects of any complexity. You will learn the material that students at top universities in the world study, but in a new way. Oh, and if we're just meeting for the first time, I'm Alexandru, the CEO at Collabos, and I'm excited to go through this journey with you. We'll begin by understanding the mathematics that made it possible to build computers in the first place. We'll see what ideas and principles guided the creation of modern computers. If you don't feel very good towards math, please give us a chance to change your mind about it. There is a huge possibility that you were simply not introduced correctly to it. Then we'll look into computer architecture, and by building a computer from scratch together, you'll get a better understanding of how these wonderful machines function, why we needed to develop new and better components over the years, and how to effectively give them instructions to make our lives easier. Knowing how computers work will make you a more efficient engineer, guaranteed. You will see that future topics make much more sense. Once you've gained enough knowledge about computer internals, you'll understand why we needed higher level programming languages, and along with them, different paradigms or thinking models that help us deal with complexity. In the section on programming, we will learn about the different ways we can program a computer, and you'll hone your skills with exercises at various difficulty levels. Having learned and practiced designing and building software, you will notice that certain structures and algorithms execute faster, while others slow down to a crawl. This is where the section on algorithms and data structures comes to the rescue. We will learn how to think about problems and solve them in an efficient way. We'll look at real-life examples where we can apply these algorithms. And we'll spend quite a lot of time doing exercises that will develop your problem-solving abilities through muscle memory. By reaching this far, you're already going to be ahead of 50% of programmers in the world. You'll know the basics of software engineering that will let you specialize in anything you want. App development, web, desktop, mobile, game development, artificial intelligence, computer vision, robotics. What's more important is you will be able to reskill easily in case you'd like to specialize in something else later. However, we won't stop here. Every computer has an operating system, you might have used one, that lets you forget about dealing with the hardware components directly. We don't really think about it, but an OS helps us a lot when writing software. Armed with the knowledge from previous lessons, we'll dive into the internals of Linux, macOS, and Windows operating systems. We'll learn how they evolved to where we are now and what we should expect in the future. Since operating systems are the basis of modern computing, we'll interact with them extensively, so good knowledge of each one of these will help you become a better professional that doesn't get scared when confronted with a different OS than you're used to. At this point in track, you will have already encountered the need for using databases, but what exactly are they and how do they work? Understanding the principles behind databases will help you design better data, leading to more sustainable and scalable software. Many programmers only have vague knowledge when it comes to this subject, working only with ORMs without thinking about what's going on under the hood. Once you've delved deeper into databases, we'll switch our focus to the tools, the programming languages themselves, as part of the Languages and Compilers section. Here we will learn about programming languages in general, not a particular one. You already know that computers only consume machine code, but how exactly the instructions you write become readable by your system is something you will experiment with here. Then we'll take an in-depth look at how the main programming language for a React.js engineer, JavaScript, works in the context of a browser's execution environment. We'll also have a look at how the language evolved to where it is now. Now that we're armed with the knowledge that lets us effectively give instructions to computers, we will learn about how to use this knowledge to create methods for computers to communicate with each other. We will start with small local networks and will expand until you have a very good understanding of what the internet is and how servers communicate with each other. This section is called computer networking. We're often computing things that a single computer would take eons to go through. To combat these problems, an idea to distribute workload between multiple systems was born. The term coined to describe this is distributed systems. Since we already know how computers communicate with each other, we'll explore how to distribute workload between multiple systems. The distributed systems concept is applied in pretty much every enterprise application. Since you now understand the building blocks of computers and how everything fits into the equation, you are ready to move on to the specialization you chose, Web UI. We'll start our journey by looking at how the main execution environment works, the browser, what it was created for, and how it evolved to where it is now. We'll learn about HTML, CSS, and browser-specific JavaScript APIs to arm yourself with the right tools for building scalable browser UIs. We'll also explore the challenges we encounter when building applications and a few popular solutions out there, as well as quick pros and cons of each. Last but not least, we'll dive into the React.js ecosystem, first by learning how to use the React.js library to build simple web applications. Then we'll analyze the framework internals, and after that, we'll look into creating enterprise software and contributing to the ecosystem. At this point, you will begin to participate in practice projects that simulate the real working environment at Collabos, with real code reviews from senior software engineers, just like you would expect on a real project. The goal is to help you gain experience by going through real problems and challenges and solving them. Wow, if you thought that's a lot, you're absolutely right. This really is the most comprehensive collection of training that you can find anywhere on the internet. It will take you from knowing nothing about software all the way to being ready for real-world projects. The awesome part is you won't even need to look for a job because you will be able to pick up tasks from Collabos. But this doesn't come easy. You need to put in the work. You need to put in the sweat. Anyone can do it if you choose to dedicate yourself. Expect to spend a few hundred hours on each section. In total, you'll need to put in at least 1,200 hours to reach beginner rank. That's about 1 to 2 years of training, depending on how much time you have on your hands to spend on this. However, you will accumulate more knowledge than others do in 4 to 5 years of academic training at a top university such as Stanford, Harvard, MIT, UC Berkeley, etc. In terms of cost, let's do a simple math. The regular monthly subscription at Collabos Academy is $20 a month. If you keep it for 2 whole years, you pay a total of $480. Once you reach beginner rank, you will open up tasks that pay approximately $30 an hour. In other words, you will need to work a whopping 16 hours to return your investment. Guess how much you'd need to work to get your money back if you finish the whole track in 1 year? What if we compare this to Stanford's yearly tuition, for example, assuming we get enrolled? You might ask though, how about those boot camps or online courses that promise to teach you how to become a programmer in 15 weeks or less? But let's settle this once and for all. Complete BS. Sure, they will teach you how to program, but that's the equivalent of less than 1 section within this track, the one on programming and a little bit about what you want to specialize in, front-end, back-end, etc. However, that's not enough to prepare you for a fulfilling career, for the demand that is out there right now. We'll talk about the reasons why in the next video.